Hello, and welcome to Controllers Tech. This video is the start of a new series on LVGL, the light and versatile graphics library, and the STM32 controllers. In this series we will first cover how to implement the library with the STM32 controller, how to use DMA and the STM32 inbuilt GPU, and later we will use the GUI to build our applications. I am going to split the getting started video in 3 different parts. Today's video will cover how to add the LVGL to the project, and how to get the display working with the simplest possible flushing methods. In the next video, we will add the touch interface to our project. And finally the third video will show the use of GPU in the STM32 boards. This series will be focused on the 2.8 inches TFT SPI display, which uses the ILI9341 controller. Here is how the display looks at the back. In today's video I only made the connections for the display part. The touch controller will be covered later, so I will do the connections in the next video itself. I will show the detailed pin connection in a while. Please note that this video focuses on LVGL, rather than the display. You should have a working library for the display you are using. I will only show how to integrate the display library with LVGL. If you have ILI9341 based display, you can use this library itself. I am going to use the Nucleo L496 board for this series. I recently bought this board because it has the support for the Quad SPI, FMC, STMMC, etc. I will cover all these peripherals, and probably you will also see some integration with the LVGL, and Touch GFX. So a lot more series are going to come in the near future. Alright, let's start today's video, and open the lvgl.io. Click on the Getting Started link. Here open the platform-specific tutorials, and the porting guide in separate tabs. In the platform-specific tutorials, they have provided the guide for the STM32 controllers. We will follow this guide, but there are some additional things we need from the porting guide also. Let's download the library first. By default the link will take you to the master branch, but we will download the version 8.3. So make sure to change it here. Like I mentioned in the beginning, we will also build the applications using the GUI. The LVGL GUI, Squareline Studio, currently supports the version 8.3.6 as the newest version. Here I took a screenshot of the software. This is why we are downloading version 8.3. We will talk about the Squareline Studio later, once we start building the application. Alright, the download is complete. Rename the folder to LVGL. Now let's create a new project in the Cube IDE. I am using the Nucleo L496 board. Give some name to the project, and click Finish. Let me clear the pinouts, and then configure the clock first. The clock configuration changes based on what board you are using, so I hope you know how to configure it for your board. Let's also enable the serial wire debug. Now we will configure the SPI in the full duplex mode. Before we set the pins, let's take a look at the connection again. Here you can see, other than the SPI pins, we have 3 more pins, CS, reset, and DC. I have connected the reset and DC to the PD15, PF12, and the CS pin to the PA4. These pins must be set as output from the MCU. Other pins are the SPI pins, MOSI, clock, and MISO. The LCD is powered with 5 volts from the STM32 board itself, and the LED backlight pin is connected to the 3.3 volts. Let's configure the pins now. I am remapping the SPI pins as per the connections made on the board. And now set the CS, reset, and DC pins as output. If you are using this ILI9341 library, make sure you name the pins here. We will use the SPI with 8-bit data size, and the MSB should be sent first. The baud rate is set to 40 megabits per second, and I am leaving it to that. We will also use the DMA, so enable the DMA for SPI transmit. The mode should be normal, and data width should be byte. In the NVIC tab, enable the SPI interrupt. That's all the configuration we need to make for now. Click Save to generate the project. In the meantime, let's take a look at the STM32 porting guide. As mentioned here, after creating the project, we need to copy the LVGL folder inside the drivers folder. And then add the path to the LVGL folder in the C++ build settings. So let's open the project folder. Now go to the drivers folder, and copy the LVGL directory here. Go inside the LVGL directory, copy the LVGL configuration template file, and paste it beside the LVGL directory. Now rename the file to lvglconference.h. Let's go back to the Cube IDE. Here the LVGL directory will not show up until you refresh the project. Alright, we have the directory, and the configuration file. Now right-click on the project, and go to Properties. Go to C, C++ Build, and then Settings. Here click on Include Paths. We will add the LVGL directory to this list, so click Add, choose Workspace, and locate the LVGL folder. Click Apply and Close to save the changes. Now open the configuration file, and change this if0 to if1 to enable this configuration. This file contains all the configuration needed for the LVGL to work. For example, this is the color depth of the display, which is set to 16 for the RGB 565 types. The memory size for the allocation is set to 48 kilobytes, but you can change it as per your need. It needs to be greater than 2 kilobytes. You can read this file, its details are mentioned on the LVGL porting guide, and make changes as per the requirement or limitations. I have enough memory on this board, so I am leaving everything to default. Now we will include the display libraries to our project. I have the files for ILI9341, and this XPT2046 is the touch driver, which we will deal with in the next video. Copy the C file in the source directory, and header file in the include directory. I have made few modifications to this library, so that it can be used with any microcontroller that has the SPI peripheral. All you need to do is change some functions like how the MCU sends the data via the SPI, the delay function, and the functions to set and reset the respective pins. If you are using some other external display, you need to at least have two functions for the LVGL to work. The first function you need to have is for setting the window, and the second function to draw the bitmap. Mostly all display libraries have these functions, so it shouldn't be that hard to find. I have added one additional function here, to draw the bitmap by using the DMA. Further in the video, I will cover the flushing with the DMA, and without the DMA. Now we have the display library, so we need to connect it to the LVGL. Let's create a new source file, and name it as lcdcontroller.c. Also create a header file for the same. This file will contain the display driver for the LVGL, and we will connect the drivers to the ILI9341. Here in the guide, they have mentioned how to do it. But to simplify it more, we will use a template for it. In the porting guide, click on the display interface. Go towards the bottom of the page, and here you will find the link to the template. Here you can see the templates for the display, for file system, and there is one for the input driver also. Before we continue with this, make sure you choose the correct version of the LVGL. Alright, now copy the template source file in the LCD controller. Also copy the header file in the respective location. Let me delete these conditions. Alright, let's include the LCD controller header file here. Also include the main header file, and the display header file. Next we need to define the display resolution to remove these warnings. Alright, let's understand these functions. We have the LV port displayInti function, which initializes the LVGL display driver. Inside this function, we have the display initialization function, where we need to initialize our connected display. Let's call the ILI9341 initialization here. Next we create a buffer for drawing. The template file lists 3 different methods of doing so. The first method creates a single buffer. LVGL will draw the display content to this buffer, and then write it to the display. This is the slowest, but easiest method to flush the content to the display. The second example uses 2 buffers. In this method, the LVGL draws the content into one buffer, while the other buffer is being sent to the display. This method makes the rendering and flushing parallel to each other. We should use the DMA while using example 2. The third example uses 2 screen size buffers, and this is used for the full refresh. This example should only be used if you are using a display which is attached to the board, or is connected in parallel mode, and not via the serial link. In this video, we will use the first 2 examples. I will cover the third example in another video, where I will use either a STM32 board with an attached LCD, or a riveted STM32 display. Let's start with the first method. Here buffer 1 is defined with the size of 10 rows. This means that flushing will take place with 10 rows at a time. Next step is to register the display driver. Let's define this descriptor as a global variable, as we would need it for the DMA callback. Here first the display driver is initialized. Then we set the resolution of the display. Set the flush callback, set the display buffer, and finally register the display driver. The flush callback is used to flush the content of the buffer to the display. This is the most important function in this file. We can simply write each pixel at a time, or write a bunch of rows at once, or we can also use DMA or GPU to send the content to the display. Once the flushing is over, we should call the LVDisplayFlushReady function to inform the library that the previous operation is over, and we are ready for another flush. In example 1, we are going to flush 10 rows at a time. Let's take a look at the STM32 guide again. Here is an example of how to do the flushing. We will just copy this part from here. Basically we will set the drawing region first, and then calculate the width and height of the region. Now we will call the drawBitmap function to actually send the data to the display. Once the data has been sent, call the LVDisplayReady function to indicate that we are ready for next flush. Alright, let's build the project now. There is an error in the LCD controller file. It should have been lvgl.h. We don't have any errors now. Go to the main file, and include the LVGL header file. We need to call the timer handler every 5 milliseconds, as mentioned in the guide. Also call the LV-tick function inside the SysTick handler. So open the interrupt source file, and include the LVGL header file here. Now put the LV-tick function in the SysTick handler. In the main file, include the LCD controller header file. Now first initialize the LVGL by calling lvinit. Then initialize the display driver. This completes the LVGL integration with our project. Now we need to display something on the LCD. I am just copying the test code given in the STM32 guide. Let's put it here after the initialization is over. Alright, let's build and flash it to the board. Here you can see the background color has changed, and the spinner is rotating just fine. So we got the LVGL to work with this board and the display. Now let's do some benchmark testing. Go to the LVGL configuration file, and search for benchmark. It is disabled by default, so let's enable it by setting this to 1. Let's comment out this part, and call the LV-demo benchmark function. Let's build the code now. We need to include the benchmark header file also. It is located under LVGL, demo, benchmark. Alright, the code builds fine again, let's flash it to the board. I will fast forward this part, and we will see the results in the end. Overall I got 9 FPS with the current settings. Actually this list is quite long, but in order to scroll it, we need the touch support. Now we will use the double buffer with the DMA, and see if there is any improvement. I am commenting out the example 1, and including the example 2. Here we have the two buffers, buffer 1, and buffer 2. There is enough RAM on this controller, so I am changing the buffer size to 80 rows. You can read more about these buffer modes in the LVGL documentation. We need to change the buffer descriptor in the driver. This time we are using the buffer descriptor 2. Inside the display function callback, instead of sending data directly to the display, we will use the DMA for the same. Make sure to comment out the display flush ready function here. Once the DMA finishes the transfer, the SPI transmit callback will be called. We will write this callback in our LCD controller file itself. Here we will call the display flush ready function to inform the library that the transfer is finished, and it can initiate a new transfer. Also in the ILI9341 file, there is a function, end of draw bitmap, in case you want to perform some operations on the display after drawing the bitmap. You can call the function from here itself. I am not doing any operations, so I am commenting it out. We should pass the address of the display driver descriptor here. In the main file we are still performing the benchmark test. Let's flash it to the board now. I will now share the pictures of some benchmark tests I performed, which will help you understand that using DMA does improve the performance a little. This is it for the video. I hope you understood how to integrate LVGL in the STM32 project. In the next video, we will include the touch driver for this display. The link to download the code is in the description of the video. Leave comments in case of any doubt. Keep watching, and have a nice day ahead.